Global Finance, Topic 7, Interest Rate Parity, Copyright Lou Gaddis. In this topic, we're going to forecast exchange rates using interest rate parity and unbiased forward rate. We learned in the last topic about purchasing power parity, and specifically relative purchasing power parity. Relative purchasing power parity says that a new exchange rate at time, say 1, is the current spot price times relative inflations. And the theory behind relative purchasing power parity is that if a country's good prices increase, say, faster than another country, the currency will have to devalue to ensure that the relative prices have not changed. The new theory, as we're going to talk about, is interest rate parity. Now, functionally, it's very easy. It's taking the same formulas and just turning them into R's. So instead of, if I'm trying to forecast, say, the exchange rate between the US and Euro, instead of getting inflation forecasts, I can look at the yield on, say, US one-year Treasury bonds and, say, one-year sovereign bonds issued by the government of Germany. Now, the theory of why you can do that is interest rate parity makes a huge assumption, and that assumption is that real exchange rates across countries are the same. So in other words, there's no arbitrage in the sovereign bond market. If a country offers you a higher yield on their bonds, it's only because they have higher inflation. So when we look at interest rates, the only reason they would differ would be because they have higher inflation. Therefore, we can use these interest rates as a proxy for inflation differentials. Now, I do want to give you a caveat. When you see a nominal rate, say the yield on a government bond, we can decompose that into the real rate of interest plus inflation. And you might also have, say, a default risk premium. Maybe it offers a few more basis points of yield because the bond might default, and maybe a liquidity risk premium. Maybe it's a small issued bond, and then if you had to sell it quickly, you might lose some money, so it offers a little bit extra yield. So when we talk about the yield on bonds, they may be composed of all these things. Now, the interest rate parity assumes that everything's the same except for inflation. So when you observe differences in bond yields, it's only inflation. Now, if I'm talking about, say, an exchange rate between, say, US and Australia or US and Canada, I'd probably say they have the same default risk and the same liquidity risk premium as the US. Therefore, I'm a little more comfortable saying the only difference may be inflation. All right, so I call this a caveat in that I don't want to use interest rate parity to forecast exchange rate between two countries in which one country has, say, a very large default risk embedded in their bonds. For that reason, when we forecast, say, the exchange rate between the US dollar and the euro, we generally use German bonds and not, say, Italian or Greek bonds, which may have a default risk premium or a liquidity premium built in. So when we use interest rate parity, we're going to forecast an exchange rate next period. It's going to be the spot price times the relative inflation rates. And if we're going to forecast for more than one period, we're going to just take it to the T power again. Again, this looks exactly like purchasing power parity. And if we're going to forecast for less than 1 year, again, we're just going to use the annualized yield on their bonds, say 1 year. And if it's for less than 1 year, we'll just take a fraction of that interest rate. So let's do a problem. So here we have the spot price of the euro at 125. US interest rates are 5%, and German interest rates on their bonds are 8%. We use that as a proxy for the Eurozone. And the question is, what is the expected exchange rate in 1 year? I'm sorry, in 6 months. So I'm going to forecast in 6 months, it's going to be equal to, and this is going to be in dollar per euro. It's going to be the current spot price, dollar per euro, times the relative interest rates, where it's dollar over euro. So that's going to be 1 plus 0.05 in the US, and for this, since it's 6 months, I'm going to do 6/12 of 5%, and 1 plus 8% and 6/12 of that for a half-year effect. Now that's going to give me an exchange rate of about $1.23. So actually in this case it's none of the above. Now you could verify this, that this makes sense, where we already said that inflation is going to be lead to a devaluation of a currency. And in this case, the Eurozone has 3% extra inflation. So over 6 months, I'd expect the euro to devalue about 1.5%, going from 125 to about 123. So that sounds reasonable. So here's another problem that we can use interest rate parity for. The dollar is selling for 115 yen today. That's my spot price. And the expected spot price or exchange rate in 1 year is 120. So what I can use is my PP or IRP formula and say that the new exchange rate, yen per dollar, over the current spot price, yen per dollar, is equal to the relative interest rates. And again, since this is yen over dollar, I'm going to have yen over dollar interest rates. And this says the US interest rate is 5%. And then we can solve for the interest rate in Japan, which turns out to be 9.57. Now another theory we're going to talk about is unbiased forward rate. Unlike in stock markets, the forward interest rate, the forward rate, is an unbiased predictor of future spot rates. Now again, that is not true if you talk about stock forwards or futures contracts. And one of the main assumptions is that currencies have a beta of 0, and that's an underlying assumption. Why? For currencies, the forward rate is the expected spot price. Now this has an important implication for financial managers. If you need an exchange rate to use for next year's forecast, all right, you could just simply go to an exchange website or Bloomberg and look at a forward rate and use that as an expected spot price. Again, you couldn't do that for a stock market. You couldn't look at a stock price, forward price for 1 year and use that as an expected spot. All right, so you're learning in say a derivatives class that really for stock markets the forward prices just reflect the cost of carry, difference between risk-free rates and dividend yields. But for a currency, it is the expected spot. This has also an important implication for those trying to hedge an imminent change in an exchange rate. Say a U.S. exporter to Mexico is concerned about a devaluation of the peso of 20%. And say the market widely believes that the peso is going to devalue by 20%. So you'd say, well, couldn't they use the forward market to hedge into an exchange rate today? Well, not really. Since the expected spot price is the forward price, when they go to the forward or call the bank and ask for a forward price, what they probably quote you is an exchange rate that's already 20% different. So you can't hedge against known exposures that the market's already anticipating because they're already reflected in the forward price. So our unbiased forward rate says that the expected spot price is the forward price. If I divide both sides by the current spot price, I can also talk about that 1 plus the appreciation of a currency is equal to 1 plus the forward premium. So that's an important equality in currencies. And that leads us to this formula here, kind of a 4-part equality here. All right, these are called the parity conditions for exchange rates. What that says is that 1 plus the expected appreciation of a currency is equal to the relative inflation rates, and that's our PPP. And then if we make another assumption that real interest rates are the same, and that interest rate differentials for sovereign bonds simply reflect inflation differentials, that's also equal to the relative interest rates. And then if we further assume that the expected spot price is the forward price, we also say that's also equal to 1 plus the forward premium of this currency F. So we can use this formula to forecast inflation rates, interest rates, forward rates, and appreciations. So let's kind of talk about this formula again. So with this equality, if you say that the euro is expected to appreciate by 3%. This formula tells you that the Eurozone must have 3% lower inflation. All right. It also implies that their sovereign bonds should have 3% lower yield. And it should also say that the euro should already be at a 3% forward premium. So that's the equality conditions for currencies. There's a relationship between inflation rates, interest rates, forward premiums, and expected appreciations. So let's look at a couple problems. Well, actually, this is not a problem. It's just helping you think about those relationships. Say the dollar is selling at a 5% forward discount to the Swiss franc, and Swiss inflation is 5. So the dollar is at a discount. Swiss inflation is 5. I'm sorry. The dollar is selling at a forward discount. This implies that Swiss inflation is 5% higher or lower. So if the dollar is at a discount, I would assume that the dollar has higher inflation, higher interest rates, and it's expected to get devalued. So this implies that the Swiss inflation is 5% lower than the US. Swiss interest rates are roughly 5% lower than the US in sovereign bonds. And the Swiss franc is expected to appreciate by about 5%. Again, it's the quality of all the conditions. There's another problem. Suppose annual inflation in the Eurozone and Sweden are 3% in the Eurozone, 0.5% for Swedish krona or Sweden. The spot price of the krona is 5.35 crown per euro. What's the 1-year forward exchange rate? So we're going to forecast the 1-year exchange rate, crown per euro. It's going to be equal to the spot price, crown per euro, times Swedish crown over euro interest rates. I'm sorry, these are inflation rates. So it actually doesn't matter whether they're inflation rates or interest rates. It's going to give you the same answer. So in this case, we need crown over euro inflation rates, 0.5% and 3%. That'll give me 522 crown per euro. And again, this seems to make sense in that the euro has 2.5% higher inflation. This exchange rate is the price of the euro, so the euro has to devalue. That's why it's gone from 5.35 to 5.22. Here's another problem. Say interest rates in the US are 3% in the US and 5% in Australia. What's the Australian dollar's forward premium? In other words, what is the expected, or what the forward price, what percentage is it above the spot price? Well, I'm going to use my parity conditions up top. It's talking about interest rates, so it's going to use, these. And it's asked about the forward premium of the Australian dollar. So these are the only two terms I'm going to use. So let me write that. Forward price over the current spot equals 1 plus R over 1 plus R. Now this problem is asking you, what is the Australian dollar's forward premium? Now remember from previous discussions, when you see, say, a forward price over a spot price, say a future price over a current spot price, that is equal to 1 plus the forward premium. And we're looking for the Australian dollar, of the Australian dollar. That's going to be equal to a ratio of interest rates. Now the question is it dollar over euro, dollar over Australian interest rates, or is it Australia over dollar interest rates? Well, in this case, we're trying to talk about the price of the Australian dollar. So if I were to have a forward price, it should be the dollar price of an Aussie in both cases. So if I had this ratio here, that would be 1 plus the forward premium of the Aussie, the price of the Aussie, quoted in dollars. So that justifies using dollar over Aussie interest rates. Again, if we're looking for the Aussie's forward premium, how will we reflect the price of an Australian dollar is to have the dollar over Australian exchange rate. So I'll do the dollar over Australian interest rates. So in this case, the dollar interest rates are 3%. And the Australian interest rates are 5%. That'll give me 1 plus the forward premium of the Aussie dollar. I'll then subtract 1 to get to the forward premium, and that number is negative 1.9%, which again makes sense. Australia has roughly 2% higher inflation, implied by the fact that they have 2% higher interest rates. Therefore, their forward price of their currency should be about 2% less, and it never works out to be exact, so it's negative 1.9%. One more problem. The peso is at a 3% discount to the dollar for 1-year delivery. U.S. inflation is 2.56. What is Mexican inflation? So this is saying the Mexican peso is selling at a discount, so it's telling you something about the forward premium. And it's also giving some information about inflation. So I'm going to set these equal to each other. Forward over spot, 1 plus I, 1 plus I. Again, we could restate this as 1 plus the forward premium. And in this problem, it says the peso is selling at a 3% discount. So they're talking about the peso. So I'll say of the peso is equal to 1 plus I over 1 plus I. Since they're talking about the price of the peso, I'm going to make sure I'm going to represent this as dollar over peso. So now I can answer this problem. 1 plus the forward premium of the peso, that was given. It's at a 3% discount, so I'm going to say 1 minus 0.03 is equal to 1 plus inflation in the U.S. Let me move this over a little bit. Over 1 plus inflation in the peso, or Mexico. I can then solve that equation. I'll multiply both sides by 1 plus IP, and then divide both sides by 1 minus 0.03. And that'll give me a solution to this problem of C, 5.7%. Now I want to finish this with bringing back some older material. When I talked about the supply and demand determinants of exchange rates, I said, well, if a country is a net exporter, that means there's excess demand for the products. Therefore, exports will lead to an appreciation. That's a plus sign there. I said if a country has higher inflation, there's less demand for the product because it buys less and less goods. I guess less demand, that's a negative sign. So inflation tends to devalue a currency. I said if a country is growing, that'll tend to appreciate a currency because there's more demand for their stocks and their property and their businesses. And then I said if real interest rates are higher in one country, that will tend to appreciate the currency. Now, the want to focus on is real interest rates. Now, that is different than what we just talked about here. Under the parity conditions, I said that high interest rates tend to devalue a currency. Now, what these are nominal interest rates. So, interest yields on countries' sovereign bonds. Now, the major assumption here is that IRP assumes that real rates are the same. Well, that may not be true in reality, but this model assumes that if there's no arbitrage, real rates are the same. So what this is only referring to is nominal yields. So there's an inconsistent treatment of R when we talk about how they affect an exchange rate. So in this topic, we talked about how to forecast exchange rates and expected appreciations and forward premiums using interest rate parity and the unbiased forward rate.